Cool guys, so we're on question 4 now. So 4.1, it says given cos A minus B equals cos A cos B plus sin A sin B. 4.1.1, use the above identity to deduce that sin A plus B equals sin A cos B plus cos A sin B. So this is 3 marks. They love this question. I've seen it in every June paper, every prelim, every final, some sort of proof with a compound angle. So what we need to do is we need to do a co-function here for the original thing we're working with. As we do a co-function, we're then going to substitute everything into this side, and it's going to end up turning into a sin A cos B plus cos A sin B. So I'm going to do that here. So we have cos 90 minus A minus B, because A minus B was our initial angle. So it's like saying 90 minus our initial angle, theta, for example. Once we have this, we can turn it into a sine. So that has given us this portion of it. Then from there, what we're doing is we're distributing this negative into both of these angles. So we're just trying to unpackage that whole angle so we can then repackage it. So what I mean by that is 90 minus A, we have times the negative in there, and then negative times negative B is positive B. At this stage, what we have is we can just repackage this guy as our first angle, 90 minus A plus B. So we have the A portion, we have the B portion, we've turned it into sine, and now we have to go ahead and substitute this into this original guy on the right side. So what that means is cos, wherever the A used to live, we have to go cos 90 minus A. Because A used to live there, but now we are repackaging the co-function where A now lives. So cos 90 minus A, this B we're just going to distribute normally, so it means we have cos B over here. And then what we have is plus sine A is what used to live here, but now we have to redistribute this 90 minus A into here, which means we have sine 90 minus A, and that is multiplied by this B we're just distributing normally into sine B. So to retrace our steps, we did a co-function of our initial reference angle. We then distributed the negative into both, and we repackaged the 90 minus A here as our first angle and distributed that into this whole compound angle on the right. Because now we're just one move away from having this whole sine A cos B sin B, because we have a co-function, which means we are 90 minus theta, placing us in the all quadrant, which means we can just turn this guy into a positive sine A. This guy stays cos B, okay, and that is what we have here, sine A cos B, and then our plus stays out there, sine 90 minus A becomes cos A. Cos A is what we want, great, times sine B stays the same. And through that move of changing it into a co-function and distributing it throughout the original, we have then turned this whole thing into a sine A plus B on the left side, because we dropped this angle, 90 minus A is sine A plus B, so we have that over here, and then we distributed the 90 minus into this whole right side to get the same compound angle on the right, and that has earned us 3 marks. Great job. Okay, so then 4.1.2, it says hence or otherwise determine the general solution of this equation. Okay, so we have sine bracket 2x plus 50 bracket minus sine 15 cos 48, these guys are multiplied together, equals sine 48 cos 15. So whenever they say hence, it means, okay, probably look at the question before, because sine A cos B cos A sin B. We have a sine, we have a cos, we have a sine, we have a cos. So it is very similar to this guy, it's just in a different format, so we'll just repackage it. But in order to do a general solution, what we need to do is take the sine 15 to this side. So a general solution, we would look if we had the same trig functions, and then we would try and divide by them, or we would see how we could factorize. But in this stage, whenever there's something affecting the angle in this guy, for example, we have a compound angle, and the best bet is to take this over to this side so we can then see what we need to do. The hence once again told us to work with some sort of compound angle, and these angles here are very specific. So what we have is sine 2x plus 50 over there, and that equals sine 48 cos 15 plus sine 15 cos 48. Or I can swap them saying cos 48 times by sine 15. So sine 48 cos 15 cos 48 sine 15. These guys are multiplying, so it doesn't matter that I changed the order of them, but that gets us closer to a compound angle. Because right now we have sine 2x plus 50. This will stay here. So we have sine 2x plus 50, and this equals sine angle, cos angle angle, sine angle. So a sine and a cos plus a cos and a sine is the same as this one that we just calculated here, which means it turns into, when we repackage it, into sine A plus B, which means we have sine 48, because this is the compound angle we are working with, sine 48 plus 15 in brackets. So we have repackaged it. We have a sine here, we have a sine here. We can just go ahead and we can simplify inside this bracket because these are just numbers. So that means we have sine 2x plus 50 over here. This equals our sine 63. At this stage, we're good to go. So we can divide by sine on both sides. So we cancel sine and we cancel sine, but we do not try and solve for the x individually, because at this stage, according to our cast diagram, this guy here was our reference angle, which meant it was a positive sign here. Otherwise, we would have had a negative here if we took something over. So sine is positive. So that means we're dealing with quadrant 2 and quadrant 1. So at this stage, we're going to bring both of these guys down into quadrant 1 and quadrant 2. So here we have a Q1. This whole angle here represents our theta, and this whole angle here is our reference angle. So usually we'd go something like theta equals x plus k 360. K is an element of z. But at this stage, what we need to do is we need to bring this 2x plus 50 down to the theta here, and this 63 down to the side as we place it in each quadrant. So that means we've divided by sine, we've figured out which quadrants we're in, and then we're going to go ahead and we're going to bring the 2x plus 50 down here because that is our angle. Then from there we have 63 because we're in quadrant 1. We don't have to go any reduction because 0 plus 63 is still 63. For quadrant 2, we're going to do the 180 minus this reference angle. For this guy, we have 63 plus k 360 because sine has a period of 360. So does cos. Tan has a period of 180. And then for 1 mark, we always just have to write k as an element of z somewhere, because then we can go ahead and we can solve for this. So we're going to keep the 2x here. We're going to take the 50 over, which means we have 63 minus 50 is 13 plus k 360. K is an element of z. Divide by 2. And we have to divide this guy by 2 and this guy by 2. And that's why we don't try and solve for the angle up here, because otherwise we might not do a reduction of the period. So 2x divided by 2 is x. 13 divided by 2 is 6.5 plus k 180. K is an element of z. And then this was quadrant 1, which just means we're in quadrant 2 over here. And then quadrant 2 is very similar. We bring down our angle. So we say 2x plus 50, and that equals, only one thing to keep in mind here is that we have to place it. This was our reference angle, which means we have to go 180 degrees minus our reference angle to place us in quadrant 2. So we have 180 minus 63, because that was our reference angle up here, plus k 360. K is an element of z. Once again, we have to write that for 1 mark, and then we can go ahead and we can simplify. So we're going to leave the 2x here, 180 minus 63 minus 50, simplify that on the next line, plus k 360 over here. K is an element of z. And then what we have, 180 minus 63 minus 50 is 67 degrees. So 2x equals 67 plus k 360. Cool. And then we have to divide everything by 2. So x equals 67 divided by 2 is 33.5. And then k 360 divided by 2 is plus k 180 degrees. And then these are our angles that satisfy this general solution, 33.5 plus k 180 in quadrant 2 and 6.5 plus k 180 in quadrant 1. And that just earned us 4 marks for this general solution. So question 4.2, it says if cos x plus 30 equals negative 2 sine x, deduce that tan x equals negative 1 over the square root of 3. This is a 5-mark question. The general theme that we've had so far has been a lot to do with our compound angles, not our double angles here, our compound angles. So the fact that we have a cos x plus 30 equals negative 2 sine x, this negative 2 sine x isn't like this guy. It's not sine 2 theta, and it's not necessarily anything up here just yet. So we can maybe have a look at that, but these guys aren't similar either. So the only move that we can really start off with in order to get the tan x equals negative 1 over square root of 3 is expanding our cos x plus 30. Okay, so cos x plus an angle becomes cos A, cos B minus sine A, sine B. So if we go ahead and we expand it here, we have cos x times cos 30 minus sine x times sine 30. And then this equals minus 2 sine x. So next move here is the fact that we have a cos 30 and a sine 30 means we have our special angles. These guys, we can either do our Nova table or our protractor, whatever method we use, or we use our calculator because they didn't specify that we can't use our calculator. So that means we can simplify the cos 30 and the sine 30. So Cos 30 is the square root of 3 over 2. And this is multiplied by cos x over here. And then minus sine 30 is 1 over 2 times sine x. And that equals minus 2 sine x. So at this stage, these guys are both over a 2, which means we can multiply by 2, so we can drop the denominator. It'll make it a bit neater for us, which means we have the square root of 3 cos x minus sine x, because both of these guys had the 2 in the denominator, which meant we just dropped them. But what we did have to do, and what we are doing, is multiplying this guy by 2, because it was only over 1, so we have to multiply it by 2, which means we have minus 4 sine x. So at this stage, it's a lot neater. A reminder that we're going for a tan x equals minus 1 over the square root of 3. So we've done some good work so far. So what we can do now is take our negative sine x over here, which means if we take it over, it becomes a positive, which means we're left with minus 3 sine x over there. What is remaining on our left side is the square root of 3 cos x, because we took this guy over, which means we're not far from a tan. A tan x is just sine over cos, which means we can move our cos down here. So we're going to keep the sine x over here. We can move the cos x down there. So we're dividing by the cos x. And then what we can do is we left our square root of 3 up here. So this guy stayed. And then we can divide by our negative 3 here. So what we have is dividing by negative 3 over there. And then at this stage, what we're going for is a square root of 3 at the bottom and a 1 at the top. So we're closer. This guy is just tan by itself. So sine x over cos x is our tan x. That's great. That's what we wanted. And then I'm just going to move the negative out in front here. So let's call that guy positive and just put the negative here, because we can either have the negative here or in front or at the top. It doesn't change the meaning as long as we only have one negative in this case. So we have minus square root of 3 over 3. And then what we need to do in order to get a square root of 3 at the bottom is we have to times by a reciprocal. So what that means is that we're timesing by 1. But if we times by the square root of 3 over the square root of 3, we haven't changed the meaning, but we have then made it easier for us to get it in this form where we have negative 1 over the square root of 3. We already have the negative here. So now we just need to go ahead and simplify this by timesing top and bottom, which means we have minus square root of 3 times the square root of 3 just becomes 3. It's like squaring a square root. And then what we have at the bottom is we have 3 times square root of 3 means we have 3 surd 3. And this equals tan x over here. And then we're just one move away because we can just cancel the 3 and the 3, means we're left with tan x equals minus 1 over the square root of 3. And that is what we wanted over here. If cos x plus 30 equals negative 2 sine x, deduce that tan x equals this value minus 1 over the square root of 3, and we have that over here. So we're on question 4.3. It says, given the expression 4 sine x cos x divided by 2 sine squared x minus 1. 4.3.1, simplify the above expression to a single trigonometric ratio. So what we have here is a 4 sine x cos x. This guy looks very similar to this guy over here, this 2 sine x cos x. But what is different is that this guy has a 4 and that guy has a 2, which means we can just go ahead and we can change the formatting, but not the meaning, saying 2 times 2, because that equals 4. And then we just keep our sine x over here times by cos x over there. And then what we have at the bottom is 2 sine squared x minus 1. This looks very similar to 1 minus 2 sine squared x. So this guy, all we need to do is take a negative out, and then we can swap the order of this and this, and then we can have it in that form, and we can turn it back into a cos 2x. So we're going to take the negative out. We have a negative, and then it becomes minus 2 sine squared x plus 1. Okay. And then at this stage, what we can do is this 2, we can keep it out there, but 2 sine x cos x, we can convert into sine 2x. So we can condense this double angle and turn it into a sine 2x. At this stage, we had the negative out there, but we can swap the order, saying 1 minus 2 sine squared x. So 1 minus 2 sine squared x, as we spoke about, is just turning into a cos 2x. And this is great for us because we have a 2 over there, we have sine 2x over here, and then we keep the minus out, and 1 minus 2 sine squared x becomes cos 2x, which means we're just one move away from simplifying the above expression to a single trig ratio. And then we're going to put the negative at the top. We're going to keep our 2 there because the positive times the negative is negative. 2 is over there, and then sine 2x over cos 2x just becomes tan 2x. And that is our final answer, having converted the above expression to a single trig ratio. So then 4.3.2, it is saying for which values of x in the interval minus 90 to 90, so x is between that range, will the above expression be undefined? Okay, so this is 3 marks as well. So what we need to do is whenever they're talking about undefined, we need to look at the denominator, because if we divide by 0, anything divided by 0 equals undefined. So we're just going to take this denominator and make it equal 0. So we have 2 sine squared x minus 1 equals 0. Then we can go ahead and take the 1 over. So we have 1 there. We have 2 sine squared x over here. We can then go ahead and we can divide by 2, bring the 2 down here. So we have sine squared x equals a half. And then what we have left is square rooting this guy and square rooting this guy. And whenever we square root an x, we get a positive or a negative outside. So we have the square root of 1 over 2, positive or negative, and that equals our sine x over here. So at this stage, what we need is the value for x in terms of angles. Right now, we just have the lengths of the sides. We're going to have to shift sign negative square root a half and shift sign positive square root a half, and then we can get our 2 angles in this range. So if we divide by sine over here and we shift it on our calculator, we're left with the angle of 45 over there with the positive square root of a half, and x equals minus 45 for the negative square root of a half, which means that is our final answer because we are within the range of minus 90 and 90. Both of these angles fall within there. And if we do any rotations adding 360, because that is the period of a sine graph, it'll take us outside of this range. So if we add 360 or subtract 360 from 45 over here, or same thing with our negative 45, it will take us outside of this range, which means these are our final answers over here. And then question 4.3.3, the final question of this section, it says without using a calculator, determine the value of 4 sine 15 cos 15 2 sine squared 15 minus 1. So it's only 2 marks, and this is a follow-on question, just like they've all been. We simplified to a single trig ratio, we got the undefined portion, and now we are here. So this thing looks a bit messy for us, but a reminder that in our previous question, we calculated and proved that this expression here, this 4 sine x cos x, we have 4 sine 15 cos 15, same formatting, just with actual angles there. 2 sine squared x minus 1, we have 2 sine squared 15 minus 1, which means we simplified this whole expression to a single trig ratio, and we made that equal, and this was the correct answer, minus 2 tan 2x, which means we don't have to try and solve for this whole thing again. What we can just do, we can plug the angle of 15 into x over here, and then we can solve for it without a calculator, because then what we have is minus 2, tan is over here, and then what we have is 2 is the angle inside there, times by 15, because x is the angle we're working with. X is 15 in this case, if we were to rework the whole thing and get to the same expression, which means we can just go ahead, we can multiply inside the brackets. So we have minus 2 tan 2 times 15 is 30. 30 is great for us. It's saying without the use of a calculator, which means we either have to use our Noah table or our protractor in quadrant 1 to get that angle. So we have minus 2 tan 30. If we were to use our calculator, we could get it, but let's do it. Minus 2 tan 30. So I'm just going to quickly draw the protractor here for these special angles. So we have this guy. This is the first quadrant of our Cartesian plane. So that means we have a 90 over here. We have a 0 degrees here. We have 3 other angles over here. This guy is 60. This guy is 45. And this guy is 30. Just a reminder, we're just making a protractor in the first quadrant here of our Cartesian plane, which means if this is our y-axis there, and that is our x-axis, when we are directly on our y-axis, we have an x value of 0. So we have the square root of 0. And then here, we just need to know this starting point. It is the square root of 4 is the y value. That is x and that is y. So as we move this way, all we need to do is we need to move this guy up by 1 unit. So we have the square root of 1. It was 0, but now our x is the square root of 1. And the square root of 4, we have to move down by 1 unit, which means we have the square root of 3 over here. And this just repeats. This x value moves up 1, so we have the square root of 2. This y value moves down 1, so we have the square root of 2 here as well. Then over here at 30 degrees, this guy was 2, so it becomes the square root of 3. And this guy here moves down 1, getting the square root of 1. A reminder that these are all x's and y's. So these are coordinates on a curved plane. And then our last thing here for 0 is the inverse of this guy, but we can just continue with the trend that this guy was 3, so it becomes the square root of 4. And this guy, the y value, becomes the square root of 0. So now we have our special angles based on x's and y's throughout. And then the only other thing is that r equals 2 for all of them. If we were to draw a radius there, a radius there, a radius there, or there, it is the same length, it equals 2, which means at this stage, tan of 30. Tan is y over x, tan is tix or o over a, which means we have to go to the 30, the angle over here for 30. We have to take the y, which is the square root of 1, and put it over the x, which is the square root of 3. So that means we are just substituting the whole thing, tan 30, we are replacing it with the square root of 1, which is just 1, because that was our y for tix, over the x value, which is the square root of 3, which means our final answer is minus 2 times 1 is negative 2 over the square root of 3. And that is how we would solve this without using a calculator, determining the value of this whole messy thing. Remembering that it was the simplified single trig ratio, and then just using our protractor or our node table to get the value of tan 30 if we weren't going to use our calculator to then solve for this. So that was 4.3.3. That earned us 2 marks and 20 marks for this whole section. Great job, guys. Let me know if there are any questions in the comments below, and otherwise I will see you in the next video.